We will wrap up section 1.3 with a review of the 2 techniques we've learned for graphing lines and a sneak preview of what's to come in the next section. 1.3.4 involves finding the intersection of 2 lines. Example 5. Graph the lines given by x plus 2y equals -6 and y equals 1/2 x plus 3. Identify the intersection point as an ordered pair. So what we have here are 2 equations in 2 variables. This is what we call a system of equations. To solve a system, we're looking for the ordered pair that satisfies both equations simultaneously. Graphically, that means where do these 2 lines intersect? So we're going to graph both of these lines and observe their intersection point. Let's start with the first line. The first line is given by x plus 2y equals -6. Notice this is in standard form. That was ax plus by equals c. We learned that it's convenient to graph a line in standard form by finding the x and y intercepts. So we will review that here. Remember, to find the x-intercept, we set y equal to 0. So we have x plus 2 times 0 equals -6, or x equals -6. Well, that was easy. Our ordered pair for the x-intercept then is -6, 0. We can find the y-intercept by setting x equal to 0. So we go to the original equation and replace the x value with 0, and then solve for y. We have the simple linear equation 2y equals -6. We can solve that by dividing both sides by 2 to get y equals -3. So the ordered pair for our y-intercept then is 0, -3. So those 2 points are sufficient to graph that first line. -6, 0, and 0, -3. Then we will connect our dots with a straight line. A ruler sure helps if you're doing this by hand. Let me try that last part again. And I'm going to label this one x plus 2y equals -6. So that takes care of our first line. The second line is y equals 1/2 x plus 3. Notice this one is in slope-intercept form, which we learned is y equals mx plus b. So we're going to graph this one starting with the y-intercept, which is given by this number right here. X is 0, y is 3. And then our slope is the coefficient of x. In this case, it's 1/2. So this was our second method for graphing lines. We'll start at the y-intercept, 0, 3. And our slope is 1/2. So we're going to count up 1, right 2. We can do that, remember, as many times as we need to. And then we will connect our dots. So connecting our dots very carefully. A ruler helps again, and labeling this 1/2 x plus 3. Now our goal is to identify the intersection point. It appears that the intersection point is this ordered pair right here, which we have labeled as -6, 0. So the intersection point is ordered pair -6, 0. Now let's double check that just to be sure. I'm going to go to that first equation and I'm going to plug -6 in for x and 0 for y and make sure that I have a balanced equation. So again, -6 going in for x in the first equation, 0 going in for y, and we can observe, yes, that balances the first equation. Let's go ahead and plug it into our second equation. We're plugging -6 in for y, and we're plugging, y is 0, x is -6. And notice 1/2 times -6 is -3. So we have 0 on the right side, 0 on the left side. So this ordered pair balances both of those equations. So we have found the intersection point of those two lines. And remember, that's what we call the solution to a system of equations. We will focus on how to solve systems of equations algebraically in the next section. At this point, you're ready to begin your section 1.3 homework.